Okay guys, so once again we've got exactly the same questions. I hope you're beginning to realize something. They can only ask you so many questions. So describe one method they use. You could have said anything. You could have said a satellite orbits around the planet taking images, sending radio waves back. I chose to write they send a rover that has a camera and send images and photos back. Right. Here again, it's exactly the same question as in the last exam. Why is this above the Earth's atmosphere? Because the Earth's atmosphere can absorb some of the electromagnetic spectrum. You guys do not write EMS in an exam, I'm just writing it shorthand. So it can, the Earth's atmosphere can absorb certain types of electromagnetic spectrum. So they have it above the Earth's above the Earth's atmosphere, so that they can detect clearer images. Also, there might be some cloud blocking, so it's better just to be up in the sky collecting as much information as possible. Right, just really the same questions. Okay, pause the video, go over to the other side, have a go, then unpause. Okay, so this is quite an interesting question. So this space telescope was pointed towards one star. It detected the same dip in brightness of the star every 150 days. Why is that? So basically what it tells you, so it's, the question is actually suggest what information this gives you about the planet that orbits this star. So if you look at this, I've just drawn a picture. So here we are, obviously not in space, but it's just a drawing. And basically what it tells you is that this planet has an orbit that comes in front of us, so that's when we're looking, every 150 days. So in other words, some of that light from this star gets blocked. Why? Because it takes 150 days to orbit this sun, and every 150 days it gets in front of us and in front of the sun, and so we see, or in front of this particular star, and so we get to see less light from that. So once again, from point A to point B, that's a full orbit. For this planet, the orbit is 150 days, right? That's a full year for this planet. And when it gets in front of the sun, it blocks our vision from the sun because it's blocking some of the light, and so to us that particular star looks dim. Next page, pause, go. Right, so these are some strange questions that they like to ask sometimes, and literally the only reason that I can see that the answer is 50 meters is because of they just want you to think what's a reasonable height for that. I mean, they asked one question once where they said, like, what is the length of a bee, and they gave you an answer of 2 kilometers, 2 miles, 2 meters, 0.2 millimeters, and other kind of options, strange options, just to kind of see whether you can understand scale. That's it. It's a weird question. Now, anyway, moving on to the next one. What we've got here is we've got energy transfers happening. So the wind obviously has kinetic energy because it's blowing, therefore it's moving. If something is moving, it has kinetic energy. The electrical generator, the generator produces electricity, so that kinetic energy is being used to make electricity, and finally that electricity causes lamp energy to be made in the lamp that is powering. Okay, pause again, next slide. Unbelievable, the same exact type of questions. Is the message getting through, guys? Do pass papers, you will be fine. Anyway, calculate the amount of heat energy produced. Again, this down arrow is wasted energy, this arrow is what energy is being made, transferred to useful. This is our total energy to begin with. So to find out how much heat is lost, you do the total energy, take away the useful energy, that'll give you the wasted energy. So we start off with 200 joules of energy, that turned to 60 joules of light energy, the remainder is wasted. So it's 200 take away 60 joules is 140 joules. And if you think about it, 140 plus 60, that's the total on this side, is going to equal to 200 joules on the other side. This is the idea of the conservation of energy. Conservation of energy, you need to know it, guys, make a note about it. Energy cannot be created or destroyed, but it changes from one form to another form. And the total energy will be the same as what you started with, it just changed from one type to another. Again, exactly the same question as on the last paper. Calculate the efficiency of the lamp. So efficiency is small number divided by big number. But which small number do we use? Do we use 60 or do we use 140? Well, it wants you to work out how efficient this lamp is. So the lamp, the good energy, the useful energy, the efficient energy is the light. So because this is the useful and the efficient energy, we're going to do 60, which is the efficient energy, the good energy, the one that we need, divided by the total energy to begin with, and then multiply that by 100, and it'll give you 30%. Again, oh my days, the same question. Constant temperature, why? Because the amount of power going in to the bulb is the amount of power going out of the bulb. The amount of power going in is equal to the amount of power going out. Gives you a constant temperature. Unbelievable. So this is about payback time. Now, what I've done here is I've just done a quick example just to make sure that I'm doing it the right way around. This is what you should be doing. So what I've said here is if I pay £100, but I'm going to pay in £10 installments per year, how many years is that going to take me to get back? So it's £100, that's what I paid for it. Pay £10 each year, it's going to take me 10 years to pay back. So what you're going to do is it's always, again, the big number divided by the small number for payback. Okay, so 6,000 divided by 250, and that'll give you the number of years. So it's 600 divided by 25, which is, so that's 4. I can't do it in my head. Okay, I'm just tired. Okay, I'm tired. But yeah, that's what it is. It's the for payback time. It's the big number divided by the small number. Big number divided by small number. What you paid for it divided by how much you're paying back each year. What you paid for it divided by how much you're paying each year, and that'll give you your payback time. Okay, so here's a chance to pause your video. So basically, the question is, why can the dog hear the ultrasound whistle but man cannot? Because humans cannot hear above 20 kilohertz. We've already covered that from the first video, or the first exam. Same questions again. And the whistle is above 20 kilohertz, so you can't hear it. So with this question, what you're going to do is you're going to use Andrea's method, what I like to call Andrea's method. You're going to call 140 meters, so that's distance, that's a measure of distance. You've got a time, which is 0.42 seconds, and you've got a speed, which is unknown. So you go to the front of your exam paper and you find an equation that has distance, time, and speed. And that's this equation here, speed equals distance divided by time. So it's 140 meters divided by 0.42 seconds, and that'll give you a speed of 333 meters per second. Notice they're giving you the a mark for the units as well here, so that's why it's important that you know the units. Last question on this section. It says an earthquake has a P wave of frequency of 15 hertz. Complete the sentences. Now, you know P waves are not sound, so these two are sound, so you can cancel them out. You know it's not part of the electromagnetic spectrum, because that is obviously raging Martians invaded Venus using X-ray guns, so it's not that, and so therefore P waves are transverse. It's just the way it is. It's just life, ladies and gentlemen. But hang on, let me think actually, because they're not electromagnetic, they're not sound, and they are transverse. Yes. Oh my days, that's wrong. Let me think about that. Now, yes, that is wrong. It's not transverse. Oh my days, how could I get that wrong? How could I get that wrong? What a shame. Because, of course, the reason why I remembered is because of my acronym, which is P waves are like, you guessed it. So I'm going to do PL, it's like it, not is, SS. So it's primary, it's longitudinal, so it's not transverse. Okay, which is really bad of me. It can go through liquids, solids, and it's speedy, just like when you need a, yes, correct. So primary, longitudinal, they can go through liquids, they can go through solids as well, and they're pretty speedy when you need a, that's correct. Okay, so that's really, really bad of me, kind of getting ahead of myself. And because it is longitudinal, it is going to be one of these two, and in this instant, it's going to be a low rumble that you cannot hear, so it's going to be infrasound. Okay, my bad. How awful is that? So just because we went through P waves, I'm going to pause the video and go through S waves. Okay. Alright, so S waves are when you go for like a if you know what I'm saying. So they're secondary waves. They can only go through solids. They're very slow, just like when you're constipated. And this one though is transverse, okay? So the S wave is transverse, whereas the P waves are longitudinal. Oh, got it, that I got that one wrong. Never mind. Just don't get too cheeky. That's another lesson. Don't be overconfident. Go in prepared with your revision tools, etc. Okay, so we are on page... there's no page. On page 14. I'm going to stop the video, make a new video. We're going to be on page 15.